This do now here asks that if you wanted to paint this box below, how much paint would you need? How could you figure this out? So pause your video and think for a second, how could you figure out how to cover the outside of this box in paint? Now, with this, it's a little weird because the box itself is obviously a three-dimensional shape. You can pick up a box, you can throw it around, you can put stuff inside of it. But to figure out how much paint you would need, that's actually an area question. And an area question, that would be a two-dimensional sort of measurement, because what you're actually looking for is the area that the paint needs to cover along the outside of the box, like on the front side here, on the top part, on the left side, and of course don't forget on the bottom, on the right side, and on the back side that are hidden from view. And this sort of area is called surface area. It's the area on the surfaces of a three-dimensional figure. And it's one of the ways you can take a two-dimensional measurement on a three-dimensional figure. And this right here is the classic example that you'll see on a lot of tests and stuff like that. Like, how could you figure out how much paint you need to cover a box? So we're here on Thursday. Don't forget, those of you who have class, periods 3, 5, and 9 today. Tomorrow we're just going to wrap up what we've done for the week. So just look at everything that happened along the way. And don't forget that homework is due. And next week we're going to start volume, which is our three-dimensional measurement situation. So on these two questions, we're actually going to find the surface area of the rectangular prism on the left and of the cylinder on the right. So on this rectangular prism, first you have to figure out how many total faces are on this. I can see 1, I can see 2, I can see 3. How many total faces are there? Well, one way to look at it is the right side here is going to be exactly the same as the left side that's out of view. The front part is going to be the same as the back, which is also out of view. And the top section is going to be the same as the bottom. So what we need to do is we need to find the areas of all of these. So the area of the red section, like on the right here, for example, that area is just 6 times 5, which is 30. The area of the blue section, right here, we have 11 for the bottom, but we also need this side right here, which we can steal from over here because it's the same thing. So that would be 6. So the area of the blue is 11 times 6, or 66 for each piece. And then for the area of the green, the top and the bottom, it almost looks like we have no measurements. But this 5 is the same as this. And the 11 right here is the same right there. So the area of the green part is 11 times 5, or 55. Now, one easy way to look at rectangular prisms, they only have 3 measurements: a length, a width, and a height. And to find the area of these 3 different types of faces, all you have to do is figure out every combination of those 3 measurements. So like the 6 times the 5, the 6 times the 11, and the 11 times the 5. Now, with this, what we need to do to find the total surface area is, of course, multiply all of these by 2 because there's 2 faces that work. So for the red side, for example, right here, there's the right side, but there's also that left side that's hiding behind over here. So every one of these is going to be multiplied by 2. So 30 times 2 is 60. 66 times 2 is 132. And 55 times 2 is 110. And now, the total surface area, all we have to do is add those 3 numbers. So we're going to do 302 centimeters, and since this is an area problem, it's centimeters squared. I know it's a three-dimensional figure, but the measurement we're taking is two-dimensional. So now, let's look at the cylinder here. And the key with the cylinder is we have to figure out what shapes actually make the outside of it. So you can see right here, this is pretty obviously a circle. So there's a circle on top. There's also a circle on the bottom. And now the real question is, what is this shape right here? This shape that stretches all the way around. So this thing goes all the way around the cylinder. The easiest way to picture this is to think of it like you think of a label on a soup can. If you peel the label off a soup can and lay it flat, you're going to end up with a rectangle. And that rectangle is obviously going to be 4 feet tall. That's pretty easy. The confusing part, though, comes in when we start to think, what is this? What is that distance right there? So let's pretend that the label, we cut it here, and we wanted to peel it off. We're going to peel it off starting that way. So let's look at the top here. Peel it off this way. It goes there, 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 there. It goes all the way around the edge of the circle. And the edge of the circle is the circumference of the circle, or pi times the diameter. So that's how we're going to figure out the area of that. So first, let's start with the circles. So the area of the circles is pi r squared, and our radius is not 12 here. Divide that by 2, and we get that the radius is 6 inches. So with that, we have pi times 6 squared, which we can do in the calculator, and we get 113.1 square inches. Now, remember, there's 2 of those, so the total area of both circles, the area of both circles is going to be 226.2 square inches. Now, let's turn our attention to the rectangle. And the rectangle is interesting because this says 4 feet, but our original measurements were in inches. So in order to change feet into inches, we just have to multiply by 12, because 1 foot is 12 inches. So instead of 4 feet, we're going to call this 48 inches. Okay? So here, the area of that rectangle that stretches across the middle is going to be 48 inches times, and now we have to do the circumference of the circle at the top, which is pi times the diameter of the circle, which is 12. And with that, we turn to our trusty calculator again, and we get 1,809 square inches. So our final answer for the surface area of this cylinder is going to be 226.2 square inches plus 1,809.6 square inches, which gives you 2,035.8 square inches. So what you want to do is figure out what are the outside shapes around the figure you're trying to find the surface area for. Find the area of those shapes, and once you find the areas, add them together. A cylinder gets a little tricky, but the important thing to remember is you have a circle on top and a circle on bottom. Those parts are easy. Then you have a rectangle. The rectangle, you just take the height of the cylinder, and that's the height of the rectangle. And then for the base of the rectangle, you have to take the circumference of the circle on top and the bottom. So you take the circumference of the cylinder's 2 bases. When you finish with your worksheet, your reflection questions are going to be to write down your strategy for solving problems like this. Try doing it like a step 1, step 2. First, I do blank. Second, I do blank. Third, try writing it out like that. It'll help you make sense of the whole process. And of course, look back at these original steps here that you have and figure out where are you or other students more likely to make mistakes. Like, hey, am I forgetting something here? Do students often forget that? Was that part tricky for me? And don't forget that your Delta Math is due Friday at the regular class time. Good luck.